Okay, so where we left off was just finding the number of G's at the bottom of the loop. And so here it is, 9.51 G's. But if you take a look at, I don't know, some sheet that I had that said what was dangerous, you would see that this is not good. So on Friday we had talked about the fact that you won't see this kind of loop in a roller coaster, and it's for this exact reason. You need a nice high hill to get your speed up, but then when you go into this circle, the radius is too tiny compared to the speed. So you have too much centripetal acceleration. You're experiencing too many G's. So we'll look at the other kind of loop before the day is out here. But let's finish the question. So the next one says, how fast is the roller coaster car traveling at the top of the loop? I just need to go to a new page. I don't have enough room. So we go back now to our conservation of energy equation because we're going from the bottom of the loop to the top of the loop. So 1/2 mv initial squared, mg h initial, 1/2 kx initial squared, 1/2 mv final squared, mg h final, 1/2 kx final squared plus E lost. Okay, so no E lost, no spring. At the bottom of the loop, no height, just speed. If you want it, so I was saying you could use here. You could also go back to the beginning, and that might be smarter to do because we know that the height and the speed exactly. Now, because I had given you the answers on the sheet, you do also know the speed here. And it doesn't make a difference because there's no friction. So in the first step, we wrote that the top was equal to here, so both of them will be equal to this spot. So I just picked the bottom because I was assuming you probably all did to get rid of your height. But if I was doing it, I might be tempted to pick the top, especially if it was on a test and I didn't know that the 40.86 was correct. Okay, but since I already scratched out the height, we have to use the bottom. And on the other side, on the top, we have both a height and a speed, so they both stay on this side. Okay, and again, there's an m in each of the three terms that are left, so we're left with 1/2 v initial squared is equal to 1/2 v final squared plus GHF. And it's asking you to find how fast it's going up there, so we're looking for VF. So bring your GHF over and multiply everything by 2. So it'll be VI squared minus 2GHF is equal to VF squared. And so VF squared is equal to, so using the bottom, 40.86 meters per second squared minus 2 times 9.81 meters per second squared, and the height is 40 meters because it tells us the radius is 20 meters, and so the height is twice the radius, otherwise known as the diameter. So the height is 40 meters. Punch it into your calculator. Don't forget to take the square root, and when you do, you should get something like 29.75 meters per second at the top. Okay, so now it wants to know what's the centripetal acceleration up there. So again, AC is equal to V squared over R. So this time it's the 29.75 meters per second squared divided by the R, which is 20 meters. And so you get an AC of 44.24 meters per second squared. Number 7, which was one that I said you could skip, but we can now do together. It wants to know how many G's does the rider feel at the top of the loop. So we had derived earlier that at the top of the loop it was AC over G minus 1. So number of G's felt is equal to AC over G minus 1. So it's equal to 44.24 meters per second over 9.81 meters per second squared minus 1. And when you do this, you get the 8.51, but this time it's oh no, I take that back, you don't, because I'm dividing a different number. You get 4.51, and then this time it's minus 1. So you end up with 4.51 minus 1, or 3.51 Gs. Okay? Which is safe. Okay? Is it? Yeah, because you're hanging inside, so it is safe, because it's 8 Gs or more that isn't. And then the last part is how fast is a roller coaster traveling at the top of this hill over here. Okay, so again, we're changing height, so we need to use 1/2 mv initial squared plus mg h initial 1/2 kx initial squared is equal to 1/2 mv final squared mg h final 1/2 kx final squared plus e lost. All right. So if we do it as if we didn't know the right answer this time, let's pick here just to. Okay, so it has both a height and a speed up there, and it has both a height and a speed over here. So the kx initial, 1/2 kx initial crosses out, the 1/2 kx final, the e lost. There's an m in all 4 of the terms left, so they all cancel. So you'll be left with this, and you're looking for, once again, the v final. So multiply everything by 2 and take this over. So you'll have v final, v initial squared, plus 2ghi minus 2ghf equals v final squared. So v final squared is equal to, the initial up there was 10 meters per second, plus 2 times 9.81 meters per second squared times 80 meters, minus 2 times 9.81 meters per second squared, and it's 35 meters over here. Okay, oops, don't forget your squared on there. So do the math, take the square root, and you should get a VF of 31.35 meters per second. Okay, so this should be fairly easy, I hope. So hopefully it makes sense. But we do still have that issue of, except it's not going to be healthy for the people at the bottom of the loop. And so what we do is we change our loop. So this is the sheet I'm going to have you work on in a few minutes, okay? And so I'll attach it here, and you can do it on separate paper. I have the printout copy for you at school. But notice that this part of the loop, the lower part of the loop, now has a bigger radius of 50 meters, and the upper part of the loop has a smaller radius of 10 meters. So it means you can still go really fast down here, but now when you do number of G's, you're going to be dividing by a bigger R, and so the number of G's down there won't be as big. And up here, you're going to be dividing by a smaller R, so you'll get a better number of G's there too. Because remember, the roller coaster guy said the ideal is to maximize terror, which is to have the number of G's as big as possible while minimizing injury. Okay, so this sheet will be your homework, which I will post in a little bit. And as well, would you please do numbers 1 to 9 on the multiple choice sheet for me? Okay, and that multiple choice sheet I gave you a while ago, it's this guy. So if you haven't done 1 to 9 on that, please do it. And these 2 roller coasters, which I will post. All right, and enjoy your snow day.